Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Education, SOE, Master's Degree Programs, Master of Arts, Distance Education, MADE, Second Year, MDE415 Research for Distance Education, Block-1 Introduction to Research in Distance Education, Unit 1 Introduction to Educational Research, Purpose, Nature and Scope.
1.0 Introduction. You have been an active participant in the process of education, initially as a student, and now as a teacher or counselor or as an educational administrator. While carrying out educational activities, you have to take decisions about how to plan learning experiences, how to organize an institutional activity like examinations or admissions, how to develop a distance education program or how to deliver a course through distance education. While taking those decisions, you must have used your own experience and knowledge. The following questions, however, always come to mind in such situations. Times is personal knowledge and experience an adequate source in planning an educational activity? Times are there other sources of knowledge? Times are there sources of knowledge that bring in a synthetic manner experiences of a large number of educational practitioners like you. In this unit, you shall briefly learn into possible sources of knowledge for the practitioners of education to arrive at more dependable and tested answers. That is precisely what educational research purports to do. In this unit, we discuss the fundamentals of educational research, namely, its purpose, nature and scope. While we shall also refer to the broad field of education, our focus will be on open and distance education, a subject of your present concern. 1.1 Objectives. On the completion of this unit, you should be able to times explain the purpose and importance of scientific research, times describe the nature of educational research, and times identify the areas in which distance education research is being increasingly undertaken. 1.2 Sources of knowledge. Human beings have always sought answers to their questions through various methods: experience, customs and tradition, deductive and inductive reasoning, and scientific approach. Information for making educational decisions come from many sources which include personal experience, expert opinion, tradition, intuition, common sense and belief about what is right and what is wrong. Each of these sources may be inadequate if you take it as the only basis for making decisions. Although experience is a familiar and well-used source of knowledge, it would have its limitations as a source of truth. Customs and traditions have been a traditional source of knowledge. This is equally true in education, where educators rely on past practices as a dependable guide. But one has to be careful that notions of past are not blindly idealized. It is wise to value customs and traditions, but be open to examine their relevance in the present context. For example, the customary or traditional notion of education is that of a face-to-face interaction. Does it imply that open and distance education is not feasible? Both deductive and inductive reasoning have made significant contribution towards developing a systematic approach to establish truth. In fact, integration of important aspects of both deductive and inductive methods led to the evolution of the scientific approach, which all of us are mostly concerned with in research. Deductive reasoning is a thinking process in which one proceeds from general to specific statements through logical arguments. Inductive reasoning derives its argument and strength from the observed phenomena. As both deductive and inductive reasoning have their limitations, it was only a matter of time that scholars integrated the most important aspects of both methods to evolve a scientific approach. Scientific approach is generally described as a process in which investigators move inductively from their observations to hypotheses and then deductively from the hypotheses to the logical implications of the hypotheses. They deduce the consequences that would follow if a hypothesized relationship is true. If these deduced implications are compatible with the organized body of accepted knowledge, they are then further tested with the help of empirical data. On the basis of the evidence, the hypotheses are accepted or rejected. This approach, or research, as source of information, has been increasingly used to prepare strategies and arrive at definite conclusions. As research systematically describes or measures reality in an objective way, it is a better source of knowledge than one's own experience, customs and traditions, deductive or inductive reasoning. Check your progress 1. Describe the roles of inductive and deductive reasoning in the scientific approach to research. 1.3 Purpose of research. It is clearly evident from our discussion in the previous pages that a researcher deals with a wide range of associations, from concrete day-to-day activities and problems to a philosophical level of search for truth. The purpose of research can be captured in a hierarchical taxonomic fashion. Times the lowest level or the first level in the purpose of research is training. Times the second level is research for problem solving, and times the third and the highest form is research in search of truth or knowledge generation. 1.3 1. Training in research. Research in education, as much as in distance education, are largely of two types. Times one leading to postgraduate degrees like MPhil or PhD. Times the other dealing with project research. Training takes different shapes depending on whether the project is a postdoctoral activity or predoctoral activity by persons who have not been trained in research methodology. Many of you who undertake programs like Master of Arts, distance education, may have been working in schools, colleges, universities or even outside these systems and have not done a doctoral program involving a course on research methodology. Even those of you who have doctoral degrees in language, linguistics or science may not have a course on research methodology. However, executing a research project in a scientific manner needs training in research methods. This course on research methodology provides the theoretical background for your research project. This print material is supplemented by interactive contact programs, primarily to strengthen the conceptual aspect of research methodology. This will also facilitate the right choice of research designs, tools and techniques. Hence, training in research methodology is an important purpose of research in distance education, particularly this program. Those who have had the opportunity of undergoing a professional course on research methodology followed by some research project would already be well aware of this course and may not need any formal input but can still refine their skills. 1st March 2002, Problem solving. The second purpose of research is diagnosing and solving the problems in the system. In this case, the system is distance education. While we talk of problem solving, it is necessary to develop a more comprehensive view of it. For instance, it may also mean a realistic understanding of a situation on the basis of data and statistics. Let us take the case of the personal contact programs, the universally practiced method of student support services in distance education. A project that undertakes to study the difference in the performance of those who attend the personal contact programs and those who do not, provides a sound empirical basis of assessing the role of personal contact programs. Similarly, most of the countries, including India, invest considerable amount of money on educational mass media, television in particular. The studies that assess the extent of media utilization shall show the differential performance of those learners who use media and those who do not, provide a revised understanding of the role of media in distance education. Such examples can be multiplied but may not be necessary. In other words, a series of studies will go into diagnosis and develop better understanding of the practices in a system. This may also include study of socio-economic background of students. Another set of studies may actually get into experimenting with an innovative solution. For example, a distance education institute can model its counseling sessions into a 2-week or 3-week module, tutorial or lecture modes, group interactive mode or group assignment mode, and so on. At the end of such exercises, the institute may assess the differential performance of the distance learners exposed to differential treatment. This will provide the distance learning institution an empirical basis for designing the sessions. Similarly, there are several alternative formats in the medium of television, e.g., lecture, interview, documentation, drama, and docudrama. The programs can be developed in different formats and their impact on distance learners assessed. There can be experiments in the administrative area as well. For example, most distance education institutes send printed instructional material by post, a common practice all over the world. Some of the universities in the Western world offer it online so that a distance learner can either read it from the monitor or download the text at his/her workstation. Some institutes deliver printed instructional material to the study centers by trucks. Students are advised to come and collect the material from the study centers. The analysis of this practice has shown that it causes minimum loss of material and is also quite cost-effective. Examples of research for problem solving can be multiplied. The important point is to recognize that research can contribute to solving day-to-day problems. All the research projects in distance education can actually take the shape of problem solving. It is important to recognize that there is no clash of interests between purposes of research for training and problem solving. Both can go hand in hand. This is particularly true for project research in MDE, where most of the participants are not trained in research methodology, but many of them are well experienced in distance education and are very familiar with the problems in the system. 1st March 2003, Search for Truth, Scientific Inquiry and Theory Development. Search for truth is the biggest challenge in research. Research in search of truth is often classified as pure research in the otherwise controversial pure applied research continuum. The search for truth, from the angle of research, is the ability to generalize and thus create knowledge. Such generalizations are derived from occurrences in repeated instances. You would have come across words like significant at .05 or .01 levels. These typical research statements basically promise that such and such instances will happen in 95% or 99% of the cases, and to that extent the phenomenon is generalizable. Generalizations are drawn primarily on two bases, namely, repeated observation in various possible situations and application of statistical designs where the variables are statistically controlled. Generalizations are drawn through tests of significance, levels of confidence, and such other types of analysis. Project research, which is the prime focus of this course, is unlikely to achieve this sophisticated level of search for truth. However, it is quite possible for you to undertake a study that could come close to generalization through application of statistical models and methodologies. Such research, however, will be based purely on quantitative techniques. There are qualitative methods of research as well. Such methods can also be applied in search of truth. Important emphasis, however, is on the use of scientific approach to research. The scientific methods can be explained in a series of steps, the exact formulation of which varies from one author to another. The steps are as follows. Times certain phenomena are observed. Times a problem situation which develops therein is noted and clarified. Times crude relationships are tentatively identified and elaborated. Times a more or less formal hypothesis is derived. Times a design is developed to test the hypothesis. Times the hypothesis is verified or refuted, and times the results are subjected to further tests and refinements. Finally, the conclusions of research are integrated with the existing knowledge of the subject. The process involves such subsidiary steps as times review of relevant experience, times manipulation of factors, times measurement of the quantities, times defining of variables, and times analysis and interpretation of data. Facts and theories. Scientific enquiry starts with facts and then moves towards theorizing. To be useful, facts must be organized, and the primary purpose of the scientific method is to develop a mechanism of organizing the facts as they accumulate and become meaningful from the standpoint of their objectives. Through empirical investigations, scientists gather many facts. As these facts accumulate, there is a need for integration, organization, and classification in order to make the isolated findings meaningful. Science must remain close to facts. It is only when isolated facts are put in a perspective by integrating them into a conceptual scheme promoting greater understanding that we approach the domain of science. When isolated facts are integrated into a conceptual scheme which promotes a better understanding of their nature and significance, it is clear that the facts have been already put in proper scientific perspective. Significant relationship in the data must be identified and explained. In other words, theories must be formulated. Theory may be defined as a set of interrelated constructs, concepts, definitions and propositions that present a systematic view of a phenomena by specifying relations among variables, with the purpose of predicting and explaining the phenomena. Kallinga, 1973. Theory knits together the results of observations, enabling scientists to make general statements about variables and relationships among variables. For example, in Boyle's law, a familiar generalization summarizes the observed effects of change S in temperature on the volumes of all gases by this statement: when pressure is held constant, as the temperature of a gas increases, its volume is increased, and as the temperature of a gas is decreased, its volume is decreased. This statement of theory not only summarizes previous information, but predicts other phenomena by telling us what to expect of any gas under any change S in temperature. Just as fact underlies theory, theories underlie facts, each raising the other like a spiral to an increasingly precise scientific formulation. Facts derive their significance from theoretical framework into which they bring facts into focus. This is well stated by Van der Laan, 1973. There is a constant and intricate relationship between facts and theory. Facts without theory or theory without facts lack significance. Facts take their significance from the theories which define, classify and predict them. Theories possess significance when they are built upon, classified, and tested by facts. Thus, the growth of science is dependent upon the accumulation of facts and the formulation of new or broader theories. This is particularly true in the early stages of scientific development, since in its early stage, Research must confine its efforts to seeking answers to highly specific and particularized problems. In the later stage, it tends to strive towards unity by breaking down the very barriers that had made its earlier progress possible. Scientific theories attempt to organize the tiny, rigorously defined bits of knowledge into a more meaningful and realistic structure. This is precisely the function of theory. Hypothesis and theory. A hypothesis, when accepted, explains the small number of facts and the relationship between them. Generalization, as the term denotes, is a hypothesis based on broader phenomena. Theory explains even more facts and their interrelations. Theories themselves range from the simple to the more sophisticated. Finally, there are laws, which have the greatest scope and generality. In spite of the strong case that has been made for the role of theory in research, it will be appreciated that a theory has to be amended or abandoned when the discovery of new facts can no longer accommodate it. Alternatively, it may be subsumed by a wider, more embracing theory when it is realized that the situation which is contained by the theory is one instance of a more general case. Theories generated by the means that we have indicated do not lead to eternal truth, rather, they should be looked upon as useful conceptual frameworks which are adequate for present purpose or a given situation. This every theory is subject to modification as and when we get new facts and evidence that contradict the generalizations made earlier on. Purpose of theory. There are several purposes to be served by a theory in the development of science. We shall briefly consider three of them here. First, theory summarizes and puts in order the existing knowledge in a particular area. It permits deeper understanding of data and translates empirical findings into a more easily retainable and adaptable form. The theory of oxidation, for instance, places into focus many of the chemical reactions common to everyday life. Secondly, theory provides a provisional explanation for observed events and relationships. It identifies the variables that are related and the nature of their relationship. A theory of learning, for example, could explain the relationship between the speed and efficiency of learning and such other variables as motivation, reward, and practice. Lastly, theory permits the prediction of the occurrence of phenomena and enables the investigator to postulate and, eventually, to discover hitherto unknown phenomena. At the time when the periodic table was being completed, for instance, certain gaps were noted in the sequence of the elements. Since theory provided that there should have been no gaps, scientists were spurred on to look for the other missing elements. In time, these were found, anticipated by theory. Theory, therefore, stimulates the development of new knowledge by providing the lead for further inquiry. Developing a theory. It is important to stress that good theories are not born out of imagination, they do not originate merely through armchair reflection. A theory is built upon collected facts. The investigator then searches, makes intelligent guesses as to how the facts are ordered, adds missing ideas or links, and puts forward a hypothesis, deduces what consequence should follow from the hypothesis and looks for further facts which are consistent or otherwise with the deductions, builds a wider generalization or conceptual framework on more facts, and eventually outlines a theory. Theories are solidly based on evidence, and they are important practical tools which enable us to advance our knowledge still further. Once a theoretical framework has been elaborated, we know what facts to look for to confirm or to deny the theory. Also, we have a conceptual framework inside with which our evidence can be tested.
Theories always involve terms that refer to matters that cannot be directly observed. For example, Gravity itself cannot be directly observed, though the effects of gravity can be. Gravity and gravitation are both theoretical terms. The terms of a theory or theoretical statements are sometimes referred to as constructs. Thus, many theories of learning refer to a motivational factor in behavior. Now, motivation is not directly observable. It is a theoretical term, or you may refer to it as a construct. The term implies that it is a construction of the scientist's imagination. Levels of theorizing. A product of all research in behavioral sciences is a set of conclusions that involves theoretical terms. These conclusions may be at a sophisticated level of theorizing or at a level of theorizing that is quite low. Most psychologists would agree that it is wise to keep theorizing down to the level that involves a minimal use of abstract terms. We may think of 6 levels of theorizing, which we briefly discuss below. Level 1. Hypothesis formation. This is the level of hypothesis formation. Any hypothesis, which is to be used as a basis for research, goes beyond the facts on which it is based. The purpose is to establish the existing state of affairs. Nearly all surveys are conducted for this purpose. Thus, students of education may conduct a survey of what the pupils think of a particular aspect of the curriculum, how much time is spent by pupils in watching television, etc. Direct study of aspects is probably the simplest to undertake, though this does not mean that it is easy to plan and execute. Level 2. Elementism. Examples of theories at this level are primitive forms of classification in terms of some significant set of ideas or idea. In the case of education and distance education, classification of abilities derived from factor analysis, or the classification of teaching acts that may be the result of extensive classroom observation, would come under the level of elementism. Level 3. Descriptive theories and taxonomies. Formulation of descriptive theories and taxonomies occurs at a more complex level than mere classification. An example of theorizing at this level is the taxonomy of human learning provided by Gagné. Gagné classified learning into 8 different categories, which vary from the most simple to the most complex. Bloom's taxonomy of cognitive behaviors can also be placed under this level. Level 4. Classification. For development of any kind of useful classificatory system, there is a need for a set of theoretical ideas to underlie the classification. The classification of animals acquired significance only after it was realized that the species could be fitted into a system in which the evolutionary relationships between animals became the basis for classification. Although the concept of evolution became a basis for systematic classification of living creatures, the theory of evolution itself represents theory construction at a higher level. In this type of theorizing, abstract ideas are introduced to explain relationships between observed phenomena. The classical conditioning theory of Pavlov falls into this class of theorizing. The dog learns to salivate at the sound of the bell because the sound of the bell and the presence of food are conditions that become linked in some unseen way in the brain of the animal. Theories at this level may still be quite primitive. For example, it is quite difficult to carry out theorizing at higher levels in behavioral and social sciences. Levels 5 and 6. Postulates and theories. The higher levels, these are levels of theorizing observed in physical sciences. At the highest level, a theory consists of a set of basic statements called the axioms of theory, which tell us what the theory is all about. Such axiomatic statements, or postulates as they are called, include primitive terms. These are terms that are intuitively understood and cannot be otherwise completely defined. One distinction that can be made between level 5 and level 6 is that the former is reserved for incomplete theories, and the latter, i.e., level 6 theories, represent the ultimate in scientific formulations. They represent the closest approximations to what one might call the accurate description of universal laws. 1.4 Nature of research. There is no universally accepted definition of research. We can, however, consider research as a systematic process of analyzing a problem, identifying the factors or variables involved in the phenomenon, collecting and analyzing information, data, on such variables to find answers to certain crucial questions. These answers contribute further to increase human knowledge. Orderliness is the hallmark of research. Research has to have an organic unity. A design also becomes essential if the knowledge which accrues from research is to be verified. 4. It must be verifiable by anybody who takes the trouble to do so. In fact, research is considered to be a formal, systematic, intensive process of carrying on the scientific method of analysis. It involves a more systematic structure of investigating, usually resulting in some sort of formal record of procedures and results or conclusions. 1st April 2001 Characteristics of research. The major characteristics of any research are objectivity, precision, design, and verifiability. Let us look at these attributes more closely. Objectivity. Ideally, research is beyond the subjective bias of the researcher. The researcher makes deliberate efforts to eliminate personal preference, resisting the temptation to seek only such data that supports his/her hypothesis. The scientific research has no onus to persuade or prove. The emphasis is on testing, rather than proving the hypothesis. The researcher is willing to suspend personal judgment and permit the data and logic to lead independently to a sound conclusion. Objectivity is achieved through standardization of research instruments, choosing appropriate research design and tools, and ensuring dependability of data. Precision. Research uses a technical language so as to convey the exact meaning to the reader, e.g., validity, reliability, random sampling, etc. The most precise expression in quantitative research is a mathematical equation or statistical finding which explains or represents the truth. Precision in qualitative research is achieved through words rather than numbers. Precise language describes the study accurately so that the study may be replicated or the results correctly used. Design. As mentioned earlier, the researcher has to have a systematic design. This will imply that any scientific inquiry will, in general, undergo the following steps: definition of the problem, statement of the hypothesis, collection and analysis of data, testing and confirmation or rejection of hypothesis, and reporting of results. Only if the research has an orderly design, it can be replicated for verification. Verifiability. This is an important characteristic of every research. Research design and findings are presented to the professional community for other researchers to analyze, confirm or reject them. Research is a social enterprise and its information is open for public scrutiny. This characteristics of research, i.e., verifiability, is related to the criteria of objectivity and precision. Only through further investigation or replication of studies can the results of a single study be confirmed or revised. Through this process, a body of new knowledge is developed and new questions identified. Verifiability is achieved primarily through two different approaches. First, analyzing the same data on the same sample through alternative analytical tools, statistical methods. Second, replicating the study on a different sample. 1st April 2002, Types of research. We can think of two major types of research: fundamental or basic research, and applied research. This classification is based on the goal or objective of the research. Fundamental research. This type of research aims at obtaining the empirical data that can be used to formulate, expand or evaluate a theory. This type of study is not oriented in design or purpose towards the solution of practical problems. Its essential aim is to expand the frontiers of knowledge without any intention of practical application. Of course, the findings may be eventually applied to practical problems that have social value. For example, advances in the practice of medicine are dependent upon basic research in biochemistry and microbiology. Likewise, progress in educational practice has been related to progress in the discovery of general laws of learning through basic research in psychology, education, and sociology. The primary concern of basic research, however, is the creation of knowledge solely for the sake of knowledge. Its design is not hampered by considerations of special usefulness of the findings. Applied research. Applied research is directed towards the solution of an immediate, specific and practical problem. This is a research performed in relation to actual problems and under conditions in which they are found in practice. Through applied research, educators are often able to solve their problems at the appropriate level of complexity. For instance, in the classroom teaching learning situation, we may depend on basic research for discovering the more general laws of learning, but applied research must be conducted in order to determine how these laws operate in the classroom. This approach is essential if scientific changes in teaching practices are to be effected. It needs to be noted that there is not always a sharp line of demarcation between basic and applied research. Certainly, applications of theory help in solving practical problems. We apply theories of learning in the classroom. On the other hand, basic research may depend upon the findings of applied research to complete its theoretical formulations. An experiment in classroom learning could shed some light on a learning theory. Furthermore, observations in a practical situation serve to test theories and may lead to the formulation of new theories. 1st April 2003, Meaning of educational research. Educational research is the way in which one acquires dependable and useful information about the educational process. It may be broadly defined as any systematic striving towards understanding, on perceiving a certain complex educational problem of more than immediate personal concern and stated in a problematic form. Harris, 1960, Encyclopedia of Educational Research. Travers, 1969, for example, defines educational research as an activity directed towards the development of an organized body of scientific knowledge about the events with which educators are concerned. Its goal is to discover general principles or interpretations of behavior to explain, predict and control events in educational situations. 1st April 2004, Scientific Approach in Educational Research. Unlike physical and biological sciences, education and social sciences deal with living humans. Hence, the subject of educational research poses much greater complexity than that in natural sciences. The usual criticism is that educational and other social science research largely emanates from ill-conceived notion of research and its application in complex human setting. The educational researcher needs the wisdom to choose research designs and methodologies that are responsive to the problem, this is, in contradistinction to the obsessive use of complex quantitative methods. The issue is that of a careful balance between quantitative and qualitative techniques of research depending on the nature of the problem, the nature of data, and even the sample drawn for the study. Although problems of discovering principles of human behavior are difficult, they are not impossible. Social scientists will need to carry out observations as carefully as are done in physical sciences. Subjective, qualitative judgments need to be supplemented by more exact, quantitative measurements which are not easy to achieve in the case of human beings. This lack of quantifying and generalizing of data quite often becomes a drawback in educational research as well. Whereas exact sciences tend to become increasingly quantitative in their units, measures, and the terminologies, in social sciences most of the matter is qualitative and does not approve of quantitative statements. We may talk of growing indiscipline, but unless we can measure it, we cannot generalize the concept. Research in education adopts both quantitative and qualitative techniques. Social sciences have not been able to establish generalizations equivalent to theories of the natural sciences or to predict events accurately. Perhaps, social sciences will never realize the objective of science as completely as natural sciences do. In fact, there are several limitations involved in the application of the scientific approach in education and the other disciplines of social sciences. Let us try to see what they are. 1. Complexity of subject matter. A major obstacle is the inherent complexity of the subject matter. Natural scientists deal with physical and biological phenomena. A limited number of variables that can be measured precisely are involved in the explanation of many of these phenomena, and it is possible to establish universal laws. For example, Boyle's law on the influence of pressure on the volume of gases, which deals with relatively uncomplicated variables, formulates the relationship between phenomena that are apparently unvarying throughout the universe. On the other hand, social scientists deal with the human subjects. They are concerned with the subject's behavior and development both as an individual and as a member of a group. There are so many variables acting independently and in interaction that must be considered in any attempt to understand complex human behavior. Each individual is unique in the way he or she develops, in the mental equipment, in social and emotional behavior, and in application of the overall personality. The behavior of humans in groups and the influence of the behavior of group members on an individual must also be dealt with by social scientists. A group of first graders in one situation will not behave like first graders in another situation. There are learners, teachers, and environments, each with variables that contribute to the behavioral phenomena observed in a setting. Thus, researchers must be extremely cautious about making generalizations, since the data obtained in one group situation may not be valid for another group. 2. Difficulties in observation. Observation, the sine qua non of science, is more difficult in the social sciences than in natural sciences. Observation in social sciences is more subjective because it frequently involves interpretation on the part of the observer. For example, the subject matter for investigation is often a person's responses to the behavior of other. Motives, values, and attitudes are not open to inspection. Observers must make subjective interpretations when they decide that behaviors observed indicate the presence of any particular motive, value, or attitude. The problem is that social scientists' own values and attitudes may influence both the observations and the assessment of the findings on which they base their conclusions. Natural scientists study phenomena that require little subjective interpretation. 3. Difficulties in replication. A chemist can objectively observe the reaction between two chemicals in a test tube. The findings can be reported and the observations can be easily replicated by others. This replication is much more difficult to achieve in social sciences. An American educator cannot reproduce the conditions of a Russian educator's experimental teaching method with the same precision of replication as that with which an American chemist can redo a Russian chemist's experiment. Even within a single school building, one cannot reproduce a given situation in its entirety and with precision. Social phenomena are singular events and cannot be repeated for purposes of observation. 4. Interaction between an observer and subjects. An additional problem is that mere observation of social phenomena may produce changes that might not have occurred otherwise. Researchers may think that X is causing Y, when, in fact, it may be their subjective observation that X causes Y. For example, in the well-known Hawthorne experiments, changes in the productivity of workers were found to be due not to the varying working conditions but to the mere fact that the workers knew they had been singled out for investigation. Investigators are human beings, and their presence as observers in a situation may change the behavior of their human subjects. The use of hidden cameras and tape recorders may help minimize the interaction in some cases, but much of research in social science includes the responses of human subjects to human observers. 5. Difficulties in control. The range of possibilities of controlled experiments on human subjects is much more limited than in natural sciences. The complexities involved in research on human subjects present problems in control that are unparalleled in natural sciences. In the latter, rigid control of experimental conditions is possible in the laboratory. Such control is not possible with human subjects. The social scientists must deal with many variables simultaneously and must work under conditions that are much less precise. They try to identify and control as many of these variables as possible, but the task is very difficult. 6. Problems of measurement. Experimentation must provide for measurement of the factors involved. The tools for measurement in social sciences are much less perfect and precise than the tools of the natural sciences. We have nothing that can compare with the precision of the ruler, the thermometer, or the numerous laboratory instruments. We have already pointed out that an understanding of human behavior is complicated by the large number of determining variables acting independently and in interaction. The multivariate statistical devices available for analyzing data in social sciences take care of relatively few of the factors that are obviously interacting. Furthermore, these devices permit the researcher to attribute the variance only to factors operating at the time of measurement. Factors that have influenced development in the past are not measurable in the present, and yet they significantly influence the course of development. Since research in behavioral sciences, including research in education, is complicated by these factors, researchers must exercise caution in making generalizations from their studies. It will often be necessary to conduct several studies in an area before attempting to formulate generalizations. If initial findings are consistently confirmed, then one would have more confidence in making broad generalizations. Despite these handicaps, education and social sciences have made great progress, and their scientific status can be expected to increase as scientific investigation and methodology become more systematic and rigorous in their research activities.
1.5 Scope of educational research. Scope of educational research can be viewed from the angles of substantive areas of education and research methodology. The two parameters are interrelated and are represented in the matrix below. Look at the screen. Let us first look at the scope from the methodological perspective. 1.5.1 Methodological classification. In subsection 1.4.2, we discussed the two categories in which all research can be fitted in. This categorization, that of basic and applied research, is true for educational research as well. In addition, educational research can be categorized differently under four types: historical research, descriptive research, experimental research and action research. Brief notes on all these types and the methods involved therein are given below to continue the discussion. Historical research. This type of research describes what was. The process involves investigation, recording, analyzing and interpreting the events of the past in order to make generalizations. These generalizations are helpful in understanding the past, building a perspective about the present, and to a limited extent, in anticipating the future. The main purpose of historical research, therefore, is to arrive at an exact account of the past so as to gain a clearer perspective for the present. And this knowledge further enables us, at least partially, to predict and control our future existence, activities. Descriptive research. This type of research describes what is. It involves the description, recording, analysis and interpretation of conditions that exist. It involves some type of comparison or contrast and attempts to discover relationships existing between variables. Much educational research is aimed at describing the characteristics of students and the educational environment. The nature of prevailing conditions, educational practices and existing attitudes must be determined before we can move on to solving problems about learners, institutional organization or the teaching of a subject. Research of this nature may not answer basic questions, but it does permit the gathering of information which serves as a basis for future research. It is detailed in Block 2 Unit 4.
Experimental research. This type of research describes what will be when certain variables are carefully controlled or manipulated. The focus is on the relationship between two sets of variables. One set of variables is deliberately manipulated, experimental treatment of the independent variable, to examine its or impact on another set of variables, dependent variables. For example, in one of the experimental studies, a distance education tutor held specially designed contact classes, independent variable or treatment, for a particular group of distance learners and studied its impact on their performance in the university examination, dependent variable. The experimental research involved systematic recording of data and scientific analysis later. This type of research leads to developing testable hypotheses, generalizations and predictions. This methodology is derived largely from the physical sciences. We will bring you more details on experimental research in Block 2 Unit 4. Action research. Action research involves the application of the steps of the scientific method to educational problems. Although it is similar in some respects to experimental research, action research differs principally in the extent to which findings can be generalized. Primary concern for action research is problem solving, hence, it is focused on the immediate application and not on the development of a theory. Many action research projects are carried out in a single classroom by a single teacher, and the others, by all the teachers in an institution or even any aspect. Its findings are to be evaluated in terms of local applicability, not in terms of universal validity. Its purpose is to improve institutional practices. A typical example of action research in a distance education institution. The institution was receiving complaints of not receiving study material in time. The material was sent by post. It was decided to send the study material to the study centers and the students were advised to collect the study materials from the study centers personally. The data on number of complaints, cost of loss on transit, additional cost at study centers, cost of transport was studied on comparative basis with the practice through postal delivery. The study indicated net reduction in complaints and the matching cost involved. In this case, the problem of delivery of material was solved through action research. We will bring you more details on action research in Block 2 Unit 4. Interdisciplinary fields of inquiry. Education is an interdisciplinary field of inquiry that has borrowed concepts and theories from physics, biology, psychology, sociology, anthropology, political science, economics and other disciplines. The methodologies used in educational research are also derived from several disciplines, e.g. systems analysis from biology, experimental designs from physical and natural sciences, observation and interviewing from anthropological sciences, testing from the discipline of psychology, and the like. 1.5.2 Area-wise classification. Educational research can be classified in several alternative forms. In fact, classifications can produce a multidimensional model. Human mind is competent in visualizing three-dimensional models. Let us look at one possible 3D classification. Figure 3. An exemplar 3D model of classification of educational research. Look at the screen. The 3D model implies that a research can be, say, in language education in the area of curriculum and at the primary level. Such studies can be classified in any of the three categories. In research trend analysis, authors often use cross-references to accommodate the findings of such studies. Open and distance education has been one area in educational research. It will be interesting to see the different areas within open and distance education that have attracted the attention of researchers. Let us examine a few such classifications in Table 1. The Table 1 reveals that there are certain common areas of research, like learners, course development and delivery, evaluation, etc. Depending on the author and her understanding of open and distance education system, some classify research into further details, e.g. Panda et al. 1997 looked at institutional policies and management, or media and technology separately, whereas other reviewers subsume research in media and technology in broader heads like instruction and course delivery. Similarly, you must have noticed that research on teaching and teacher behavior are taken as one area. There are voluminous and famous works on research on teaching by Travers and others. You will read more on research areas in open and distance education in Unit 3 of this block. Table 1. Classification of research in open and distance education. Look at the screen. 1.6 Summary. In this unit, you have read that there are various methods, for example, experience, authority, custom and tradition, deductive and inductive reasoning, by which you can gather and create knowledge. But of all these approaches, the scientific approach, which is an integration of deductive and inductive approaches, accrues as the most systematic and objective method. We also discussed the meaning of research in general, which can be roughly thought of as systematic inquiry. An important step in scientific inquiry is theory development, and we discussed the complexities of theory development at various levels. The nature of educational research has also been discussed in this unit, with a brief description of various types of educational research. Under the scope of educational research, we have included many fields of education in which research is undertaken, e.g., curriculum, educational administration, economics of education, etc. Thank you. Subscribe our channel for more updates. We will see you with the next chapter.